Hey everyone, welcome back to the DxePrep video. And in this video, this is going to be a combination of all the Exponent videos. And what we're going to do is we're going to try to evaluate this and simplify this. So, this looks really complex at first. But we notice one key thing, that there's a parentheses, which means that we must try simplifying the inside of the parentheses before we move on to the -2 over here. Because, remember PEMDAS. So, let's try doing exactly that. So, let's start with the numerator. We notice right off the bat that there is an x squared and an x cubed. And by the product rule, if the bases are the same and there's two different exponents, we can just keep the same base and add the exponents. So x squared times x cubed is going to be the same thing as x to the power of 2 plus 3, which is just x to the power of 5. So we're going to rewrite that as, we're going to do that first. So it's going to be 4 times x to the power of 5 times y over 16 z times y to the 4th to the power of -2. And now when we look over here, there's really nothing that we can simplify in the numerator. So now we're going to set our sides in the denominator. And there's nothing we can simplify in the denominator. So now let's try simplifying from both the numerator and the denominator. So we see here that 4 and 16 are like terms. That means they might be able to be cancelled out. So 4 divided by 16 is simply just 1/4. So that's exactly what we can rewrite this as, 1/4. And you may also notice that there's another set of like terms in here, y to the power of 4 and y. And you guys may remember from the quotient rule that y to the power of, that any number a to the power of m over a to the power of n is going to be the same thing as a to the power of m minus n. And that's what we see here, because this is a y to the power of 1, and then there's a y to the power of 4 in the denominator. So this must mean that the final answer is going to be y to the power of 1 minus 4, which is -3. So we're going to rewrite this over here. So this is going to be y, 1. We can eliminate the 1 because 1 is just a constant, and anything times 1 is just itself. So we don't really need that. So it's going to be x to the power of 5 over 4z y to the power of -3, the -3 coming from what happened over there. And now we have a -2. So what I would recommend over here is distributing the -2 to every single term over here. And we're going to see what that entails. So when we distribute the -2 to x to the power of 5, that becomes x to the power of -10 over, we see over here that this is going to be the same thing as 4 to the power of -2 times z to the power of -2 times y to the power of 6, because the negatives cancel each other out. And now we're done with the parentheses and the exponent over here, so we can just focus on the inside. And we see there's a lot of negatives, meaning that a lot of things need to be flipped around. So first of all, we see that 4 to the power of -2 needs to be flipped around, and z to the power of -2 needs to be flipped around. So we can just flip both of those around, and that gives us 4 squared times z squared times x to the power of -10 divided by y to the power of 6. And x to the power of -10, since it's a negative, this can just go down into the denominator. So I'm just going to do an arrow over here so we can just, because I don't have space over here, and that's just going to be the same thing as 4 squared z squared divided by y to the power of 6 x to the power of 10, because the -10 went into the denominator. And now the only thing we left to simplify is just the 4 squared. And 4 squared is 16, so this gives us 16 z squared divided by y to the power of 6 x to the power of 10. And that is the answer to this expression over here, and that's how we simplified it. So I hope you guys got a much better understanding of how exponents work through different rules in this entire series, and maybe apply it to different questions. And in the next series, we'll start looking at factoring and its use alongside with the distributive property.